Okay, now some of these are going to be every bit as simple as they seem. The only thing we're trying to pay some attention to here is that you need to express the equilibrium constant as the coefficients are written. So remember, in some of these, I might ask you to add two reactions together, and you might have to multiply through by a 6 on all the coefficients. You have to do that same thing to the equilibrium constant. So in this case, this one is going to end up being in this case, the products. So in this case, that's CH2, Cl2, and it is literally raised to the 16th. And then you're going to have H2, and that's raised to the 8th. And then you'll have the reactants on the bottom, and that turns out to be this one when you go through that. So I've jumped to this second problem now, and this is kind of a very brief version of that kind of problem where I do ask you to manipulate the equations, and you have to do the same things to the equilibrium constant. So in this case, the way you want to proceed always, whether there's just one reaction or you have to add or manipulate 4 or 5 of them, always write down what you want. And in this case, what you want is, we're finding the equilibrium constant, right, for this reaction. That's what it's saying. What do we do to that first one to make it equal to the second one? And in this case, the only thing you have to do is reverse it. You don't have to do any multiplication or anything like that, just reverse it. So when we reverse it, the new K, so we'll say that's K for this second reaction, is equal to, when you reverse it, you have to invert so that's going to be K1 in this case. Let me check that answer. So indeed, in this one, you're going to take, so 1 over the one you're given, which is 3.8 times 10 to the 4th, and that is this answer. Well, let's see, what is it? 10 to the minus 5th. 2.6 times, that one is what I get. Now I've switched to the third problem, and sometimes you're given a Kp when your concentrations are all gases and they're given in pressure units, atmospheres, and sometimes you're given Kc when you can either calculate the concentration from gases in a volume, or if you're given the actual molarity of the solutions, then it is a K sub C. And this is simply a problem where I ask you to go back and forth between the two, and it is a formula problem. That problem will be given on the equation sheet. This is the one right here. The only trick on these kind is figuring out what delta N is. Delta is what it always is, and that means it's the products minus reactants, and it's the moles of the gas. So in this case, we have 2 moles of product minus 3 moles of reactant gas, so it is a delta N of minus 1, and therefore you multiply by the gas constant. That's the 0.0821. So remember to use that. It's going to be the 0.0821 gas constant, and then we're going to multiply by, this has to be in K units, it is already in 200, and then we raise that thing to the minus 1, and then we multiply it by the Kc, and that gives us our answer. In this one, that turns out to be, so when I just punch those values in this one, I end up and I get 6.1 times 10 to the 10th.